we're going to look at some of the different properties of matter. For your reference, this is going to be Chapter 3 in your book, and some of the information will be in Chapter 12 for this unit. Our objectives for this unit should be to be able to classify matter as homogeneous or heterogeneous, a pure substance or a mixture, an element or a compound, the difference between metals, nonmetals, and metalloids, and solutions, colloids, or suspensions. You can skip the next two slides on the paper in front of you on the shoe classification activity. We won't be doing that, and the matter flowchart we'll come back to at the end. So the first thing, a basic definition between homogeneous versus heterogeneous matter. If matter is not uniform, then it is considered a heterogeneous matter. If the matter is uniform throughout, then it is homogeneous. We're going to go through some examples of each of these next. Some examples for you of homogeneous matter include salt water, apple juice, and dust-free air, which is a mixture of nitrogen, oxygen, argon, carbon dioxide, water vapor, and other gases. These are all homogeneous materials. The matter is uniform throughout. You can't see the salt or the water. You don't see the other materials in the apple juice. You can't pick out the nitrogen and the oxygen atoms in front of you like you could in a matter that is not uniform. So these are all homogeneous. Another example of a homogeneous matter would be brass. It's a solid mixture of copper and zinc. Brass is an alloy, which means it's a mixture of metals. All alloys, which are mixtures of metals, are going to be homogeneous. So remember from our beginning definition that matter that is not uniform is heterogeneous. So you can see in this cup of oil and vinegar salad dressing, there's a layer of oil floating on top of a layer of vinegar. The matter is not uniform throughout. Therefore, this is a heterogeneous matter. Here are some more examples of heterogeneous substances, or substances that are not uniform throughout. Milk, cream, granite, these mixtures are not uniform throughout their entire substance. So here is a list of materials. On the next slide, I have whited out the correct answers. There is the left-hand column for you to list the materials that are homogeneous, and the right-hand column to list the materials that are heterogeneous. Go ahead and take a moment, pause the video, and decide which material would go where. Would it go under the column for homogeneous, or would it go under the column for heterogeneous? Take a minute and see if you can decide. Flat soda pop, cherry vanilla ice cream, salad dressing, sugar soil, aluminum foil, black coffee, sugar water, city air, paint, alcohol, iron, beach sand, pure air, and spaghetti sauce. Whether each one is homogeneous or heterogeneous, pause the video now. This is the correct answers for what you should have come up with. Again, remember our column on the left, homogeneous, means that the matter is uniform. Heterogeneous means the matter is not uniform, or not equal amounts throughout it and evenly within it. Next, we're going to look at the difference between pure substances and mixtures. A pure substance always has the same composition, and pure substances can be either elements or compounds. Elements are substances that cannot be broken down into other substances chemically or physically. Examples would be things that are on the periodic table, such as sodium, carbon, and gold. Elements are always composed of identical atoms. A copper wire is made up of all copper atoms. An aluminum foil sheet is made up of all aluminum atoms. A compound is going to be composed of two or more elements in a fixed ratio. The fixed ratio is where we get the chemical compound formula. The properties of a compound are going to differ from those of the individual elements. For example, in table salt, we have sodium and we have chlorine. Now, table salt is important for your body. We need sodium chloride as a compound to send signals between cells and for our muscles to contract and relax. However, sodium by itself and chlorine by itself are going to be poisonous to your body. They are not going to be substances. You don't want to go and drink any chlorine. You'll get sick. Another example of a compound includes water. This is hydrogen and oxygen atoms bonded together in an equal proportion. There are always two hydrogen atoms attached to a single oxygen atom. A mixture can be defined as something that has a variable composition. So an example would be soda. It's a mixture of carbon dioxide and sugars and syrups mixed in with some water as well. Coffee would also be a mixture. Depending on how strong or weak your coffee is, you're going to have different amounts of different materials, different amounts of water for a weaker coffee versus less water for a stronger coffee. So we've already discussed the heterogeneous and homogeneous. Recall that heterogeneous means that the matter is not uniform. Homogeneous means the matter is uniform. With a heterogeneous mixture, again, not being uniform, it's going to have regions that have different properties from other regions. For example, if you were to pour sand into water, you're going to have, sand is going to have a different property than the water does. And we're going to have two distinct materials that are in this mixture. If we have a homogeneous mixture, also sometimes called a solution, the composition is uniform. We don't see any materials in it. We wouldn't very easily separate the materials. We wouldn't see any layering or chunks in the materials. Again, remember the word homogeneous means that the matter is uniform throughout. So we don't see the other matter in a homogeneous mixture. So we're going to try to identify substances versus mixtures. There's a list of materials here. On the left-hand side of the next slide, everything's been whited out. Some of these materials are substances, some of these are mixtures. I'd like you to take a minute, pause the video here, and see if you can determine which are substances and which are mixtures. So this is what your solutions should look like. Keep in mind that substances are going to be pure, so they include pure elements such as sodium, oxygen, iron, and nitrogen, and they also contain elements in equal proportions or ratios. So that's going to be things like water, carbon dioxide, and table salt. Mixtures have a composition of many different things mixed together. Sometimes they might have some layering. They can have different amounts of different things at different times. So if you were to make cake batter, you might put more sugar in some cake batter than in other cake batter. And so it's a mixture. The composition of the amount of sugar can vary. You can skip this slide on your notes. For those of us who are visual learners, you can look at this image to see what the structure of different pure substances and mixtures look like. In an element, we have just one single type of atom. If I had molecules of an element, we would have O2, so there are two oxygen atoms here, or perhaps we have something such as H2, still the same element, but two molecules attached to one another. In a compound, I'm going to have different elements. So maybe this one is CO2, and these are carbon dioxide molecules, or maybe it's water, and these are water molecules. But they are still going to have an equal ratio of each element. If I have a mixture of elements and compounds, a good example of this would be air. Air is a mixture of elements and molecules of an element. N2, O2, carbon dioxide is a compound. So we can see that we have many different things put together in this mixture. One last practice for you. And there's a few more in the following slides for you to practice with. Gasoline would be a homogeneous mixture. Again, we can't see any of the different parts, and so homogeneous would mean that it is uniform throughout. Copper metal, copper is all the same element, and so it is a pure substance. The rest of the slides are not in your copied notes, but you're welcome to take down notes and practice. So a stream with gravel at the bottom, that would be heterogeneous because the gravel is not going to be uniform throughout. If I had chunky peanut butter, that would also be a heterogeneous mixture because I could have different amounts of peanut chunks in it, depending on if I want extra chunky or not extra chunky.